In this video, we're going to find the derivative of a function using implicit differentiation and the product rule. It says using implicit differentiation, find dy dx of the following equation. So we're going to start by taking the derivative with respect to x for each piece. So we're going to do the derivative with respect to x for y times sine of 4x minus 6y and that's equal to the derivative of negative 3xy plus the derivative of 3. Now you can see that we have a product rule and then another product rule, so I'm going to kind of label these. This will be like the first product rule and the second product rule. So we're going to put 1 here, and then that would be u prime, v prime. So for the first piece, we're going to have u is y, and v is sine of 4x minus 6y. Now when I do the derivative of y with respect to x, I'm going to get just dy dx here, 1 dy dx. But I'm not going to write the 1 because we don't need to write the times 1 piece. When I do the derivative of sine, I have a chain rule here, so I have cosine of 4x minus 6y times the derivative of 4x minus 6y, which the derivative of 4x minus 6y would be 4, and then the derivative of negative 6y would be negative 6 dy dx. So I'm going to write this as 4 minus 6 dy dx. And then that would be cosine of 4x minus 6y. Go to part 2, and that would be u is negative 3x, u prime is negative 3 when I take the derivative of that, v is going to be y, and v prime, derivative of y would be dy dx. Now I'm going to go ahead and actually do the multiplications here. So I've got u prime times v, so I'd have sine of 4x minus 6y. And I'm going to write dy dx out front here, so that'd be dy dx times this. And then we have y times this whole function here. So I'd end up with plus 4, I'm going to distribute the y, so it'd be 4y minus 6y dy dx. When I distribute that y to each term there, cosine of 4x minus 6y is going to equal, so that's the derivative of the left side, that's the product rule. Derivative on the right side, we have negative 3y, and then plus, well actually minus, because negative 3x times dy dx, we'd have minus 3x dy dx. Now I need to get dy dx on the same side. So I'm going to distribute the cosine to each piece here. So we get dy dx sine of 4x minus 6y plus 4y cosine 4x minus 6y minus 6y cosine of 4x minus 6y. I don't really like writing the dy dx piece behind here, but that's what we're going to do. And then that's equal to negative 3y minus 3x dy dx. So I need to get all three of these terms on the same side with the dy dx. So I'm going to move this term to the right side by subtracting, and I'll move the 3x over to this side. So I get dy dx sine of 4x minus 6y minus, I'll put the dy dx out front now, so dy dx 6y cosine 4x minus 6y plus 3x dy dx is going to equal, when I subtract this over and leave the negative 3y there, I get negative 3y minus 4y cosine of 4x minus 6y. Factor the dy dx out, I get dy dx is equal to, well, dy dx parenthesis sine of 4x minus 6y minus 6y cosine 4x minus 6y plus 3x is equal to negative 3y minus 4y cosine 4x minus 6y. We're going to divide this to the other side, and we get dy dx is equal to negative 3y minus 4y cosine of 4x minus 6y all over sine 4x minus 6y minus 6y cosine 4x minus 6y plus 3x. I do not see anything to factor out of any of this, so this should be our derivative for the above equation.